Here's an introduction to angles in the unit circle, 13.2. To start with, we're going to show you how you can sketch angles and then find angles that basically have the same position as the angle that you sketched. And angles that have the same position but different values are called coterminal angles. Co meaning you're in this together, and terminal meaning you terminate or you end. To find a coterminal angle, you're simply going to be adding and subtracting multiples of 360, because if you do a 360, that spins you all the way around and has you face in the exact same direction that you were to begin with. Alright, so we want to sketch 115 degrees. Start with the coordinate plane, and whenever you go to sketch an angle, and your book might say an angle in standard position, you start on the positive x-axis and you go counterclockwise for positive angles. So I want 115 degrees. Well, 115 degrees would be past 90. 90 would bring me up to the y-axis. And it would bring me to the second quadrant, another 25 degrees. So about there. 90 plus 25 is 115. So that's a sketch of that angle. I am now going to find 4 more angles that would end up in that same position. Find 4 more angles in that same position. All I need to do is add the multiples of 360. So I could say if I'm at 115, I could add 360, and that would put me at 475. That would look something like this. I would start here, I'd go all the way around and then back. I'd end up making kind of a spiral deal there. That would be 475 degrees. So don't have your spiral connect, continually get bigger and bigger with it. When you're drawing it, I've seen some people there where they accidentally make this connect. It looks like a circle, and that can be, well, that's confusing for me. Can't imagine what it would do to you. Okay, get rid of that. You can continue to add 360s to that if you want to find other angles that are coterminal. So 475 plus 360 will put you at 835. Or on the flip side, you could also go clockwise, and to go clockwise, you're going to go negative. So I could start with my 115 and subtracted 360, and that put me at negative 245. Graph of negative 245, it looks something like this. You'd still start right here, but you go clockwise. There's 180. I'd have to go 65 more, and it looked like that. There's negative 245. And hopefully you can end up seeing you'd be facing the same direction here as you were up here. It's the exact same way. Doesn't look perfect, but that's just my drawing skills. I could find another one. Subtract another 360, and that gives me a negative 605. That's how you find coterminal angles. I would encourage you to go ahead and try the second example on your own, see if you can sketch it. Find one positive, one negative, and then check your answer after you have unpaused it and see what I came up with. Alright, so if you paused it, here's what we got going. Negative 120 would still start on the right-hand side. Negative tells me to go clockwise. This would be negative 90. And then I'm going to go 30 more. So it looks something like that. 120 degrees. To get a positive angle with it, I'd add 360. That'd give me 240. To get another negative, I could subtract 360, or I could subtract some multiple of 360. 720. 1080, 1440. I didn't say which negative I wanted. I just wanted a negative. This is the quickest negative to get, negative 480. Okay, so that is finding coterminal angles and sketching angles when they're in degree measures. We're now going to delve into radian measures. And to discuss what a radian is, I will look at what's called the unit circle. I'm calling this a unit circle right here. And the reason why I call it a unit circle is because it's a unit circle if the radius is 1. So when the radius is 1, you have a unit circle. And the distance around that unit circle then would be simply 2 pi, because 2 pi r is how you find circumference. If I put a 1 in for r, I get 2 pi. I could say that if I went for a walk around this circle, I would walk 2 pi radians. Or I could say I walk 2 times 3.14, 6.28 radians. And the radian is basically the same thing as a radius. So in this case, the radius was 1. Maybe it's 1 foot. So if I decided to walk all the way around, I would go 6.28 feet. If the radius was 2, how would that change? Well, then I would walk double that. I'd walk 12.56 feet. The main thing to get out of this is there are 6.28 radians. 1, 2, 3, 4, 5. Here's 6, and this is a 0.28 right here, all the way around the circle. Talking about distance around a circle in terms of radians is different than talking about the degrees. You know, like we did a geometry review. We said, you know, if this right here was 60 degrees, then this needs to be 60 degrees. That's one way to measure that arc. Well, the reality is it's not 60 degrees. In fact, I can tell you how many degrees it is because it's supposed to be 1 radian. This is a radian. How many radians are there in a circle? 6.28. How many degrees are in a circle? 360. How many degrees are in 1 radian? Simply find yourself a simple little ratio here. Divide it out, 360 divided by 6.28, and you got your degrees in a radian. Which is about 57.3. So if you're on the outside of a circle and you walk 1 radius distance, you have gone 57.3 degrees around the circle. If I take 57.3 and I multiply it by 6, 1, 2, 3, 4, 5, 6, I won't quite get 360. But if I multiply it by 6.28, that'll get me to 360. So a radian is about 57.3 degrees. There's 2 pi radians in a full circle, and more importantly, what we'll be using on the other side is there are 1 pi radians in half a circle. 1 pi is equivalent to 180 degrees. You know, another way to write this right here, I could have said there's 360 degrees in 2 pi radians, just leaving it in terms of pi. Well, I can simplify the 360 and 2 down to 180 over 1 pi. So here's a conversion we'll be using. 180 degrees is the same as pi radians. It's like conversion ratios you've had in the past, you know, 5,280 feet in a mile, 12 inches in a foot, those types of things. This is just a true fact. There's 180 degrees in pi radians, and vice versa. Okay, so on this side, what we're going to do in a few things, we're going to convert degrees to radians. And to do that, all you need to do is multiply by pi over 180. We'll leave it in terms of pi, so we won't actually use and multiply by the 3.14. Then we're going to go radians to degrees, and that's just multiplied by the reciprocal conversion rate. And then finally, we kind of got to go back to where we came from, where we were finding coterminal angles. I didn't have defined coterminal angles that were in radians, so we're going to do that. And then you're just going to do that by adding 2 pi's or subtracting 2 pi's, because that's what gets you all the way around. You're 135 degrees. Want to sketch that? 135 degrees would be 90 plus 45 more. Should be dead center right there. 135 degrees. What's that in terms of radians? You take my 135 and I multiply by pi over 180. That way my degrees cancel. And I'm left with pi, which is radians. I'm left with radians. Well, you can take the 135 and divide it by 180 and do a little math frac on your calculator. Or you can divide them both by 45. 45 goes into 135 3 times, goes into 180 4 times. Whatever you do, you're going to end up with 3/4 pi, or 3 pi over 4. And that's what 135 degrees is. Now take a look over here. Hopefully that makes sense. All the way around is 2 pi. Therefore, halfway across is 1 pi. I'm saying 135 degrees is 3/4 pi. I'm saying that you've gone 3/4 of this red right here if you start on the x-axis, positive x-axis, and go over to my ray that I drew. Hopefully you're going, yeah, that makes sense, because there's a quarter left. There was 45 degrees left. 45 is a quarter of 180. Next one, 270. 270, start here. You go 90, 180. 270 is the negative y-axis. And we're going to turn this into radians. Well, first let's see if we can reason it out. From here to here is a pi. And from here to here is another half a pi. Doing a 180 is making a pi turn. And then you got another half, for a total of 1.5. This should be 1.5 pi, which is the same as 3 pi over 2. We're going to write them in improper fractions, as improper fractions. Now let's see if the math works out. I'm supposed to take 270, multiply by pi over 180. I can reduce, I can cancel these zeros. And I can say 9 goes over 27 3 times, and then 18 twice. And there I get my 3 pi over 2. So 3 pi over 2 radians is the same thing as 270 degrees. I encourage you to try the 540 and then come back in after pause and see how you did. All right, here's our 540. 540 is bigger than 360, so this is going to be all the way around. And then how much bigger than 360 is it? Well, it's 180 bigger, so it's going to put me out here, which is basically, it's a 180 degree turn. So 180 is coterminal then. Well, if I go all the way around, that's 2 pi, and then I go then I go the other side, that's another pi. This should be 3 pi. From here to here is 1 pi, from here to here is 2 pi, all the way back to here is 3 pi. Every time I go 180, I go an extra pi. So this should be 3 pi. Let's check it out. Zeros cancel, 54 over 18 is 3. 3 pi radians. Any odd number pi is going to be the equivalent of a 180. So 3 pi, 5 pi, 7 pi, 9 pi, 11 pi. Or you go the other way, negative pi, negative 3 pi, negative 5 pi, negative 7 pi. All those end up doing a 180. All even pi's end up back at a 360 or back facing where you start with. So 2 pi, 4 pi, 6 pi, 8 pi, negative 2 pi, negative 4 pi, negative 6 pi, negative 8 pi. They are all facing to the east. If you think of your coordinate plane in terms of a map, you're facing east. All odd ones are facing west. Okay, and we'll go the other direction. Convert each radian measure to degrees. All right, so I've got 2 pi over 3. 2 pi over 3 means I'm going 2/3 of the way over. So if I went all the way over like this, that would be pi. I only want 2/3 of that. So 2/3 of that would be something like that. That's 2 pi over 3, or 2/3 pi. Well, that's between 90 degrees and 180 degrees. How many degrees is it? Here you're going to multiply by 180 over pi. Pi's cancel. 180 divided by 3 is 60. And 2 times 60, 120 degrees. Okay, so this is equivalent to 120 degrees. 2/3 of 180 is 120. Then I said find a positive and negative coterminal angle, and I want you to do that in radians. To do that, you're going to take 2 pi over 3 and add 2 pi. And you're going to take 2 pi over 3 and subtract 2 pi. Couple ways to do that. It seems like throughout the day, most people were going common denominator, so this would be 2 pi over 3 plus 6 pi over 3. 6 over 3 is 2, so that's common denominator. Add those up, you'd get 8 pi over 3. And this one would be 2 pi over 3 minus 6 pi over 3. Which would be negative 4 pi over 3. Top one's 2 2/3 pi. 2 2/3. 2 pi means go all the way around, and then you go 2/3 more. And negative 4/3 pi is the same as negative 1 1/3 pi. Negative 1 1/3 pi, that's what this is right here, would be negative 1 and then a third more. Negative 1 or negative 4 pi over 3. Same thing. Coterminal. I encourage you to try the 5 pi over 4 on your own and then check your answer with me. Five pi over 4 is basically 1 1/4 pi. So if I was going to graph that, I'd go 1 pi and then a quarter more. That'd be dead center there. That's 5 pi over 4. So that should be 180 degrees plus 45 more. It should be 225 degrees. This part's 180, and then you got 25 more, or 45 more, because it's halfway down there to the 90. So 225. Let's do the math. 5 pi over 4 times 180 over pi. That gets my pi's to cancel. 180 divided by 4 is 45. And 5 times 45 is 225. So this is the same as 225 degrees. Coterminals, 5 pi over 4 plus 2 pi turns into 5 pi over 4 plus 8 pi over 4, which is 13 pi over 4. And then you got 5 pi over 4 minus 2 pi would be 5 pi over 4 minus 8 pi over 4, which is negative 3 pi over 4. And the last one, not very different here, it's got a negative here, so we're going to graph that. Reminder to go counterclockwise, or clockwise on that one. Go 1/6 of the way over, so you can divide your lower quadrants here into 6, and then this would be 1/6 of it. How many degrees in that is that? It's between 0 and negative 90. I know that. It should be closer to 0. Well, you just got to keep in mind pi is basically 180. So you got negative pi over 6 times 180 over pi. Pi's cancel, and you got negative 180 over 6, negative 30 degrees. So I always think of pi as basically 180 degrees. You can replace it that way. Coterminals, negative pi over 6 plus 2 pi, negative pi over 6 minus 2 pi, negative pi over 6 plus 2 is the same as 12 pi over 6. And negative pi over 6 minus 12 pi over 6. Here you get 11 pi over 6, and here you get negative 13 pi over 6. This wraps up day 1 of our 13-2 notes. I will do day 2 in another video. Thanks for watching. Have a great day.